Good morning, everyone. We are approaching or at 9 a.m. now. Morning, Jen. Good to see you. Thanks for joining this morning. So we're having everyone roll in. So I think we're at 9 o'clock. So we'll get things rolling here. Good morning and welcome. And it's exciting to see everyone here interested in on-farm research and the work that Alberta Grains and Olds College has been working on and what we have moving forward. For those who don't know me, my name is Jeremy Boychin. I'm the Director of Research, Agronomy, and Extension at Alberta Grains. I've been involved with the Plot to Farm, the on-farm research program at Alberta Grains for about 6 years, essentially since its inception. And the main goal of this was to help develop an approach to work alongside with farmers to answer agronomic questions on their farms. We as Alberta Grains invest a lot of dollars into research at universities and research stations. And one thing we've learned through this process of on-farm research is that some of the most valuable insights come when farmers take that research and test it on their own farms. On-farm research really allows producers to test ideas on their own farms, their soils, their equipment, their management systems, and the programs that we'll share today from Alberta Grains and Olds College help provide a structure and support for farmers to test those questions on their farms. So in today's webinar, we'll be going through those two examples of Alberta Grains and Olds College's programs. First, we'll look at the Plot to Farm program. We'll talk a little bit of how it works, what the value of on-farm research is, and a little bit about how we implement trials and how to sign up for that program. And we'll give a few examples of trials we've done in the past, maybe to spark some ideas on your own farms or the farms you work on. And then after that, Olds College will share uh, the more data-driven example of on-farm experimentation, or OFPE for short, led by Dr. Felipe Karp and Daniel Steffner from Olds College. So they'll be sharing insights from 2 years of trials across Alberta of this data-driven on-farm research program, looking specifically at seeding rates and nitrogen rates. This program can expand well beyond those two examples, which the future will hold kind of what this kind of program can do. But they'll give a walkthrough of what they've learned and what the program looks like and how producers can get involved with this program. So before we get started, a couple housekeeping items. For any questions that you have throughout this webinar, feel free to open up that Q&A chat that you can find at the bottom of the webinar and ask questions. At the end of each webinar, we'll go through a Q&A session for the presenters. And we'll answer your questions there. You can put stuff in the chat too, but it's easier for me to catch questions in that Q&A. We again, and it looks like everyone's doing this, we encourage everyone to introduce themselves in the chat. Let us know where you're from and what you do. We're excited to have you all here today. And we'll be keeping all the attendees muted, just to keep things simple and to not have any background noise or any issues that way. And if you experience any technical difficulties, generally what you can do is just log out and log back in. It'll solve 90% of the problems. If it doesn't solve the problem, feel free to send a message in the chat to our team, and we'll look to resolve that as quickly as possible. So thank you again for joining us today, and we will get this started. And our first presentation on Plot to Farm. I will actually do the first piece of that, and then we'll be bringing in Rob Dunn, who is the Plot to Farm coordinator, who will provide additional details on how we implement on-farm trials and how to sign up. So I'm just going to go ahead and share my presentation here. Oop, I stopped it. Where'd you go? Okay, so the Plot to Farm program, this is again a program that we've had running for 6 years here at Alberta Grain, and has really become a staple for conversations and extension and agronomic management for farmers across Alberta, and has really grown uh, over the past 6 years. Um, and I want to start this conversation kind of talking about the why of on-farm research. And this is really shaped over my time implementing on-farm research and working with farmers to implement on-farm research. So I stole a lot of this slide from Dr. Brian Bears out of AAFC Lethbridge. And this table or this visual on the left there demonstrates some unpublished data that came from a recent research project that he had conducted across Western Canada, looking at the gaps of wheat production in Western Canada. And this is an average across Western Canada. And what he did was looked at the yield potential, so the genetic yield potential of wheat across Western Canada, and that's spring wheat. And what he found, based on his modeling, was that the average yield that's achievable in Western Canada is around 74 bushels. And this will vary across different regions depending on rainfall, but this is an average, and it's just kind of to paint a picture. And what they found, based on data from directly from farms, is that yield average is actually just shy of 50, so 47 and a half. So it's a 35% yield gap that we see, where producers are missing on potential yield that they can capture on the farm. Now, we're not going to be able to close that yield gap 100%. There's going to be economic pieces that tie into that closing that remaining generally 18% of that yield gap just becomes non-economical. The amount of inputs and management required to reach that 100% gap closure is just, it's non-economical. And what Brian talks about when he looks at this and reaching or closing that yield gap is the triangle on the right. And again, I stole this concept from Brian, but it essentially paints the foundation for how we help close that yield gap. And the foundation there is a productive soil on your farm, a healthy field ecosystem, a no-till or reduced till methods to conserve soil health on top of that, and then good crop diversity. So good crop rotation on your farm is going to really help increase the yield potential on your farm. And then the top piece of that is G by E by M, which is genetics by environment by management. And that piece is the interaction between the variety or the genetics that you're using, the environment that you're growing it in, and the management that you implement on that farm. And the interaction between those three pieces, if fine-tuned in a way that's appropriate for your genetics and your environment, can help close that yield gap. And that's where I want to tie into on-farm trials, because we end up investing in these small plot trials at universities and research stations at AFC, and it gives us very strong insight into management practices that can help increase yield and profitability on the farm. But where we really see the strength is where farmers take that information and implement it as trials on their own farm with their own genetics, the varieties that they're using, and the management practices and the environment that they're growing their crop in. So it allows farmers to take that information and test it in their own local knowledge, right? Their own systems, and their own soils, their own rotation and equipment and environment, and really see, what does this mean for me? What does this mean in terms of implementation, in terms of yield, in terms of potential economics, and really help answer some of those questions, or add some more pieces of information of how we fine tune our genetics and environment and management practices on our farms. So really acquiring that local knowledge, this is something I always say to farmers. You look at private companies in different sectors, and generally there's a research and investment or research and development portion of their budget that they utilize to help push their companies along and continue to advance. And I kind of relate these on-farm trials to that same picture of, what are you doing to invest in your own research and development on your own farm to kind of push your own knowledge and advance your farm. And on-farm research is a really good example or way to do that. And I've seen different ways, we implement on-farm research, or I've seen farmers implement on-farm research, and probably the easiest and most common that we see is a strip trial. So, hey, I want to try something. I'm just going to run one or two strips across the field and see how that compares to the rest of the field. Very simple, very easy way to do that. And it gives you a rough idea of what things might look like. The challenge there is without the replication that we see with stronger field scale trials is our confidence level in the ability for that response to be replicated across an entire field or multiple fields becomes weakened. And this is where a strong field scale replicated randomized trial can really, although it takes a little bit more work, can really solidify and strengthen some of the data that you get back at the end of the year to make stronger decisions for future crops. So pays more attention to calibration and data collection, where that trial is placed and how many replications we're putting in and what the structure of that trial looks like across the field. And it really minimizes the question of, is this a real response or is this because of just an area that I put a strip trial in the field that I'm seeing this response? So it allows us to move forward in a more strengthened way. So historically, looking back 2020, we implemented two trials as kind of a pilot. And then you can see over the past 6 years, the amount of trials that we've done now 46 across Alberta, between winter wheat and spring wheat and durum wheat and barley. We've implemented quite a few trials in quite a few ranges of different topics, ranging from row spacing to fungicide application, nitrogen rates, and biostimulants. And then in 2025, which was our most recent and largest year of trials, we had 12 trials across the province, ranging from durum and barley and spring wheat and winter wheat, looking at plant growth regulators and biostimulants, seeding rates, and fungicide timings. Um, so these are producer-driven ideas where they come to us and say, this is something that I'm asking on my own farm. What's the economic return of this? What's the application look like? What's the comparison based on what I'm being sold by either agronomists or sales reps of products? What does it mean for my genetics, my environment, and my management on my farm? So I'm going to pause there and hand it off to Rob Dunn, who is our coordinator for Plot to Farm, and he's going to talk a little bit more about the details of implementation of on-farm research.
Thanks, Jeremy. I'll just get my slides up here. All good? Let me just,
Looks good, Rob.
okay. Except did I unshare? No.
No, you're still good.
Get my correct window back up. Yeah. So yeah, thanks, Jeremy. And one of the things that we do, of course, with the program is Alberta Grains is providing that support. And one of the really important things is that we work with an agronomist or we work with your agronomist in terms of helping you to implement the trial. And one of the things I wanted to kind of and that's kind of been my role in terms of working with Jeremy and with Alberta Grains um, as a consultant, is to try and provide that support so that we can get some of these things right in terms of the trial planning and design. And what I wanted to talk about is just a few things like that. Once you've decided on a question that you want to look at, we start thinking about site selection on your farm, and you might have a field in mind. We want to kind of think about, is it something that makes sense in terms of the rotation? Is it typical for the farm? We want this to be, if it's going to be good information that you can kind of go forward on. Things like historical management, what could affect some of that site variability, things like that background fertility level. Was the site recently manured, and was there hail in the last year or two that might have affected the way that something might respond on the field? was the field previously split into two different crops or two different fields. These are just such important things because, we want to get information if you're investing this time into a trial. We want to make sure are we getting and answering the kind of questions and getting reliable data from the site. So just an example of a field where we were thinking site selection, and here we're trying to think about minimizing that variability, perhaps if we can find the area that works, appropriate size for the equipment logistics. If we're thinking about a seeding or a fertilizer or something that's centered around, the seeding operation in terms of the trial treatments, then that's going to be often kind of a smaller area that's needed in the field. If we're talking about something that is say a fungicide or a PGR application, that kind of a trial, we might have treatments that are 120 feet wide, so we might be looking at a fairly big area of the field. But this was a particular trial by way of example where we said, okay, we've got a seeding rate trial. We look at the field that the farmer has identified or that you've identified, and then we say, okay, here's a really good area where we can do a seeding rate trial. We'll talk a little bit about the results of this particular trial later on, but this was the farmer had a 40-foot drill. We're doing 3 seeding rates, 4 reps. So we've got a nice 25 or 30 acre area of the field that just works well for that kind of a situation. Well, also in the design and kind of the protocol that we work out for the farmer and for the agronomist is thinking about things like where there's a need for calibration and equipment settings, and we just like to kind of build that in just because it's just we get in a rush in the spring, or we get in where we just want to make sure are we getting the right rates out there, and especially just on the right here where we're maybe looking at a kind of a biostimulant type product, let's make sure that we've got the rates correct. And then things like proper timing for the treatments, for in-crop treatment. So we'll be thinking those things through and making sure that we've got the products and things on hand so that we can get those products out there. We always like to have the agronomist there when the trial is being seeded or when these treatments are going on, just to kind of help to make sure we're getting them in the right spot in the field. And we'll talk a little bit about some of the trials that are a little bit maybe more straightforward and some of the ones that are a bit more complicated. In my career, I always seem to get the really complicated ones. I don't know about you, but the data collection is so important too. And we part of the reason why we want to provide some funding support to the agronomists that are working on these projects is we want to have good data collection. And so we want to be able to have someone that can get out there and do the timely plant counts, observations in the field to see what's happening. And then, of course, why is it at harvest that we're always harvesting at these trials at night? But sometimes we'll get a weigh wagon in if the farmer has access to a weigh wagon. A lot of times we're just relying on those calibrated grain carts to do the work. But again, here's one of the farmers up, at one of the trials, grabbing a grain sample, and obviously we want a good grain sample, representative grain sample from the plot. We'll send that into SGS for analysis. Jeremy mentioned about replication and randomization, and here the type of trials we're talking about with plot to farm, we're talking about strip trials. So we're just sort of saying, yeah, let's not just do a simple comparison of 3 treatments, but let's replicate that. So here we have just a design where we've got 4 replications or 4 blocks. And really it just increases the strength of the data. And, a statistician and a scientist will always tell you more reps are better, but sometimes we only get maybe 3 reps. 4 is nice. But we're really trying to kind of get at that whole thing about, are the differences real or due to chance? And just a few thoughts and comments on types of trials and degree of difficulty. And I always seem to get the more difficult trials with some of the farmers I work with. But, some of the really more basic trials are things that are a bit more straightforward, where fertilizer rate response, we're just varying the rate. We need to coordinate that and make sure everything's right. But things like seeding rate response, even at top dress N, if we're talking about a blanket rate of fertilizer, and we're just going to go in and do replications of a top dress. versus maybe where we have differences in rates compared to where we're putting a lower rate area in the field ahead of time and then putting that top dress. So varying the timing of the same rate can be a bit more complex. But PGR benefits, fungicide benefit, does it, is it providing a benefit or not? A biostimulant effect. Some of those can be fairly straightforward. In terms of getting a little more complicated, if we're trying different fertilizer types, an enhanced efficiency fertilizer or a variety comparison, where we have to kind of clean out the drill and put in another variety and go out. And so that, does require a little bit more effort at seeding. Seed treatment comparisons, likewise, can be kind of complicated because, we're going out there maybe with two different seed lots and we're trying to get everything planted in a timely fashion. Sometimes it goes awry when you don't get it done all in the same day, and then it's all of a sudden you're seeding 3 or 4 days later, and that just complicates life a little bit for some of our analysis. But PGR timing and product type, where we're looking at different comparing different products. Likewise with fungicide, or maybe we're trying a couple of different biostimulants, or we're looking at the timing of the same biostimulant as a seed dressed versus an in crop or something like that. And so those get a little more complicated. Some of the really complicated ones are where we're talking about multiple variables, and sometimes it just really can't be done with a straightforward approach. It's possible, and we like to look at possible designs. Something like ultra early seeding, if you were thinking about doing a trial like that, you got to get to the field several times maybe. And then what's happening at harvest, right? If we're talking about seeding or cropping system comparisons, those can get complicated. Likewise with weed control systems. We look at those. I mean, I'm really interested to look at how we can do those in a straightforward manner and get some good data. Soil amendments, likewise, we have to really think through and be prepared for a bit more complex situation for the farmer, particularly, and sometimes at harvest with some of these things. So we try to take that into consideration when we're thinking of the type of trials. Just kind of a quick review on the plot to farm process. The farmer, is, as Jeremy said, thinking about what that question is. Farmer is providing the inputs on this. It's their investment in terms of research. The agronomist is there to help the farmer and collect and submit that data to Alberta Grains. And Alberta Grains, we are helping with that trial design. That's kind of been my role here this last couple of years, providing some of that technical support. And then we do the analysis and report development. So the way it kind of works is that a farmer, as a farmer, if you're interested, you make an application. We're going to review that. We're going to get back to you then and start building and working on an implementation plan that considers all those things like your equipment and what's needed in terms of on the site. Then there's the implementation of the trial. And we're going to attempt some randomization and replication and then basically just kind of walking through the steps here in terms of getting to the point where we have some results that are analyzed and we share those results. So that's kind of the general process, but it all starts with you kind of deciding, here's something I want to test, and so let's look at that and build a plan. How are we doing for time here? I know I did want to just share maybe just a couple of examples if we have time here. And these trial results are online, and we'll kind of show you where you can find those. But this was the one trial that we showed an example of in terms of the site. This is a winter wheat seeding rate on cold front winter wheat that a farmer wanted to do. And this is down in Granham, down in the dark brown soil zone. You can kind of have a look at the rainfall from harvest to seeding, from seeding in the fall to harvest. It was a little dry in the spring, and winter wheat struggled a little bit down in, well, I think across Alberta really, but this actually turned out pretty good. Here's just kind of the layout in terms of that location in the field that made sense in terms of, okay, we've got a 40-foot drill. We can go in and get one combine strip on that to get a yield measurement and a quality. And so there's kind of the replication that we had for a 4 replicate by 3 treatment trial. And then, yeah, here's the kind of analysis of the data. So that data is submitted by the agronomist after harvest, and then we are looking at what were those densities. We kind of nailed the densities. We were targeting 25, 30, and 35 plants per square foot. You know, uh, basically the density, we hit the densities pretty close on this particular site. That isn't always the case with winter wheat, where you can have some winter kill losses, but you can kind of see the densities there. And our yields, actually, our better yields were with the medium and low uh, seeding rates, and so again, in a lot of ways, that sort of supports some of the previous work that's done that where we kind of need to achieve in that sort of 20 to 25 plants per square foot to get kind of optimal yields. And so we were kind of our range of yields that we picked for this trial were kind of on the high side, but that higher yield obviously with the kind of spring conditions we had this year didn't do too well. That site didn't have any herbicide required, and that was just the benefits of winter wheat. And that was kind of interesting that even at that lower plant population of 25, we had really, really strong competition. So that site never got sprayed for weeds. And that farmer decided to repeat that trial in 2026. Let's look at these things over a couple of years. And so we've got another trial in and hoping for more rain this spring. Here's another example of Jeremy showed the list of some of the trials that we did. We did quite a few PGR trials last year. And this is just one example of a PGR trial, an irrigated site at Strathmore. And so 14 and a half inches of rainfall plus irrigation. It was 120 bushel acre wheat yield in that field. I kind of throw this one up. This is a 3 replicate trial. This is an example where we had kind of set up the trial where can we go in with a second application, a second PGR, we were going to go in with ethereal. So that's why kind of our treatments are kind of laid out so that we were kind of prepared to go in with a second PGR, but the timing just didn't work in terms of that situation. One of the things that can go wrong with trials, and this is an example of one where, oh man, the farmer, because of the way that the crop was laying, he had to harvest at an angle. So we couldn't actually capture yields off this trial. And we tried to capture yields off of a yield monitor, but the data, because of kind of multiple combines and a number of things, we weren't able to do that. But fortunately, we were out there with a drone, and that's part of the thing with the PGR trials. We get high resolution drone imagery for the field. And then Philippe, who's going to be presenting here in a few minutes, did his magic in terms of doing the analysis. And we did have a nice response to the PGR treatment at this site. So I just throw that up by way as a sort of a second example of one of the trials this last year. If we wanted to really quickly, and I won't dwell on this one, but a more complicated trial is where you look at, wow, let's look at fungicide timing. And this was an irrigated durum wheat field down in the Turin area. And here we're going to go with a timing 1, 2, and 3 at stem elongation, flag leaf, and head emergence. So you really have to be on your toes as a farmer and an agronomist on a trial like this, where we're looking at an application at timing 1 and 2, application at all 3 timings, and application at timing 2 and 3, where we're looking at just flag and head. And so we've got different products. We're using a different product there at our timings 2 and 3. So again, a complicated trial. This is an example of a trial where, while it wasn't statistically significant, there was a trend for better yields with the timing when we had a timing at head treatment. And so I say, okay, well, when we apply the statistics, we're looking at that variability between sites. And so even though we had a pretty nice little sort of 10% yield bump when we had that timing 3 in there. And this could be even more complicated if we just had the T3 timing, a 4 treatment trial, but that's getting a little crazy sometimes in terms of logistics. So just in wrap up here with the program, Alberta Grains provide some compensation for the agronomists so they can be there to help you implement the trial and the data collection. Alberta Grains helps you with the farm and field specific trial design. They provide a research kit, all the flags, the rain gauges, all the paraphernalia that you need for a trial. We do, Alberta Grains does the quality analysis on the samples that are submitted and the analysis and reporting. And if those trial reports are available online, and I or Jeremy look forward to hearing from you if you're interested. So, and with that, I'm probably a little bit over time, so let's stop sharing.
Thanks, Rob. Thanks for that breakdown of how things work and how we implement trials. Um, we do have one maybe comment, Marvin. I'm not sure if it was a question, but when we talk spring wheat, CPS, hard red, and special purpose feed vary a lot in yield in his area. It could be 50 bushels an acre or over 100 bushels an acre. Um, so yeah, I mean, we will do trials on any of these classes of wheat. We don't stick specifically with CWRS. We will look at CPS, feed wheat, or anything that falls into that category. We're happy to take a look and implement trials on that. Variety trials are always an exciting opportunity when a farmer says, "Yeah, I want to go through the work to test varieties and compare them." Um, so if it's something you're looking at, Marvin, we're happy to work with you to implement anything. Ah, yes, talking about Brian Barris. So Brian Barris research, I do believe was specific to CWRS wheat. Okay, so no other questions popping up. If you do have questions on that, we can address them at the end too, but we will move on now to Daniel and Philippe, who will talk about the on-farm precision experimentation work that they're doing.
Perfect. All right. So let's get started here. I'm just gonna make sure that this thing goes away. Uh, Hide the video panel. There we go. Perfect. Hope everyone still can see us. Can I get just a confirmation of that, please?
Yeah, it looks great.
Perfect. Thanks, Dan. Okay, also, my name is Philippe Carp. I'm an instructor researcher here at Olds College, and I'm here today with Daniel Staffner, which is the project lead for our Smart Ag Applied Research team at Olds College as well. And here we're going to talk about this presentation that we titled Your Field, Your Rates, Lessons from On-Farm Precision Experimentation that we've ran already, some of the trials, and what's ahead for us for 2026. Now, just piggyback on everything that Jeremy and Rob just talked about to then discuss first, not even what is on-farm precision experimentation, or as was mentioned before, for short, OFPE, but rather like why. And obviously, we start from looking at like when we are doing any experiments in fields, we start usually with plot trials, which, as Jeremy mentioned, they're great and they have their place. So when we're breeding, when we're doing a few adjustments to our rates and so on, and trying to identify a few management practices, but they do have an issue in terms of scalability. Like how many of these trials can we run and collect the amount of information we need from some of these trials, as well as the applicability. How much something that's coming from a farm so far away from you can apply to your management practices. But there's a logical evolution there, right? Which is then what we just heard from Jeremy and Rob in a sense of going there into strip trials, right? Which then now they bring it into your farm. They have their piece in this whole puzzle, right? Where now you basically are trying to gather that information more closer to your reality. But still, we face a few issues, right? We do have some operational challenges. So sometimes what's happening is we are having to harvest like at the center of that strip, right? So we leave a few pieces of that specific trout to be harvested later on, which creates some operational challenges, weight wagons, and so on and so what. But they have their place, right? And you just seen some great results that Rob presented. But still, there was something very interesting that Rob pointed out, and that's what we aim for when we do either small plots or strip trials, is that we try to avoid the variability that exists in a field simply because we're trying to understand the effect of that specific trial. Now, the thing is, with this lack of variability, we're not mapping that. But we know that when we go to our fields have different elevations. Also, if we look at our yield, we see that our yield changes throughout our fields, and we have like some high yielding zones, some low yielding zones. And we want to know how that specific understanding that we had from a specific strip trial would perhaps happen in different parts of our field. So there should be a clear evolution there as well, right? Going from strip trials to something else. And then that's when there's place for on-farm precision experimentation, so OFPE. So we basically understand there is variability in the field. So therefore, when we implement trials, we try to implement trials all over a field with something like what you see here on the screen. So these two trials you see, they're from the same field, ran in the same year, with urea and seed rates on the same field, same year, same season, right? Now, these were generated using a platform from the University of Illinois. There's a project down there called Data Intensive Farm Management, for which we've been working with and partnering with. And that's how these plots, these trials were created. And then if I was sitting right there and watching this presentation, the first thing that would come to my mind would be, this guy might be nuts. He was just talking about operational challenges with strip trials. Imagine running something like this. Well, except that we might be missing one great piece of this whole puzzle, is that we have precision agricultural equipment, hence the name On-Farm Precision Experimentation, that we can use to implement these trials. So using the existing precision ag technology, such as variable rate and yield monitors, we can import these trials into the machine, then later on harvest them using our yield monitor or our combines with yield monitors, and then be able to map that. So instead of us having issues with trying to avoid some areas and so on, we kind of like just follow through with our operation like it would be. And then later on, we deal with that on the data analysis. Now, how do we actually do OFPE? So I have a little bit of an example here of how we set it up, as well as how we implement something like this. So let's imagine this here on the screen is a piece of a field or a field that we have, right? So this orange rectangle. Then what we have now are these green lines that would represent the guidance lines. So the AB lines for the seeder, for example. So we have our seeder, 60 foot wide. We go there, we seed this field, then we seed a couple passes, and then we have a certain trials laid out. Then another couple passes, more trials laid out. After you've done that, you carry the season as usual. Nothing changes, everything follows us as you expected. Then when it comes time to harvest, we also give you guidance lines for your combine. Then you just come with your combine and you would harvest those. But note something there. My seeder was 60 foot wide. My combine has a header with a 50-foot header. There's a problem there. Something's not going to match perfectly. Well, but that's not that big of a problem, because we collected data from one pass. We collect data from two passes. Yeah, maybe the third pass will be partially in two different trials. But we can either use that information and kind of calibrate based on how much of each one of these areas have been harvested, or we just simply remove that. We already have two good passes for that combine. So there's two ways for us to manage that. Now, let's take a moment to appreciate technology here. And what we're about to show you is not like data that we came up with, but actually data came out of one of our fields last year. So this is as applied information from one of our fields with these trials implemented. So far, it looks great, right? Now, there's something very interesting, which is that our plots are 90 foot wide in this scenario. However, the seeder, the drill we used for this specific field, was actually 60 foot wide. So wait a second, how is that possible? Well, the beauty of variable rate technology and section variable rate that allows us to, at one point in this field, have this seeder actually implementing one trial and a half of its portion, and the other trial and the other half of its length, so, or of its width. So this is what something like this could provide to us. Now, what are the objectives from running on-farm precision experimentation and that we've been aiming for here with this project? Well, first of all, is that the producers in the center, like what just Rob and Jeremy just talked about, right? your operation, the knowledge produced to you is the center. And what we try to avoid here is having any disruption in your operation. So using the technology, we have to implement some of this to avoid any issues. Now, with the results we get, what you now receive is localized insights. So this is not only like for your field, but also for regions within your field. And obviously, it's going to be for a specific year with specific conditions. But next time you're seeing the same field or similar fields with similar characteristics with an expected weather that will be similar, you can use that information. And you can also use that information to now fine-tune anything else you do. So you end up having, as a result from this, actionable strategies to implement in your field. Now, what do these actionable strategies look like? The aim for this project is actually to identify optimal economical rates for seed and nitrogen fertilization, both at the same time, right? And that's important because we're not talking just about, oh, it yields more, but we're also talking about, yeah, it might yield more, but if your cost is higher, that doesn't make sense. So it's something for you to apply in your own operation. Now, what do we have so far as results from 2024 and 2025? So out of the trials we ran, 71% of the trials, and that means like we actually had a total of, there we go. We had a total of 4 trials in 2024 and 11 trials in 2025. And that means that some of these trials, let's call them actually fields, because we had nitrogen seeding rates happening at a few of these same fields. But 71% of the time, farmers could reduce their input rates and get a higher profit. But that's not the case for everyone. 10% of the cases, there were situations where increasing the rate would actually provide you with the best result. Or even you could be at the optimal rate already, but you're only going to know that if we actually evaluate that. Now, if you ask me like, Felipe, how does a trial like this look like? Well, after implementation, we have this image that I'm going to show you all in this specific slide. And you're going to see that we can actually see the trials in this specific field. So this is one of our fields here at Olds College. And you can actually see those rectangles throughout the field. And what I'm going to do right now, I'm going to just plot over the trials, so where we implemented the trials, and then remove it. And you're going to be able to see that they match perfectly. So, for example, you can look at an area, for example, with low nitrogen, and you see that the crop is actually senescing quicker at that specific location. So this was towards the end of the season. So I'm just going to do that quickly again so you can see. And there you go. So it's actually pretty cool. That means that we can implement these trials using the technology we have. But what kind of information do they bring to us? If we look into a field basis result for that specific field, and we look at urea rates specifically, what we can see is that we aimed for 218 pounds an acre, and that was what our agronomist would suggest, right? However, and this I'm considering as flat rate throughout the whole field. However, when we tested and consider still like as uniform rate or flat rate, the most profitable for us in this field with the conditions we were in that year was actually applying 102 pounds an acre of nitrogen. That would actually allow us to make $14 more an acre, which is interesting, right? So now we are saving the usage of nitrogen. Also, we're making a little bit more money. But if I was there also, I'll be thinking, great, this is flat rate, Felipe, but you mentioned about regions within a field, and that would be interesting to know. Yes, for sure. So what if now we look at seeding urea rate per management zone in a field like this? So here are like this field broken down in 3 management zones created specifically for this presentation. And then what we did was to gather all those trials we have and place them, basically find the ones that fit within each one of these zones and perform an analysis. And here's the result we get. Obviously, no shock here. The high productivity zone is providing us with one of the highest profits here. However, the lower seeding rate with the higher nitrogen was the one that provided us with that profit. Versus what happens at the medium productivity zone, where actually the original, the farmer's choice here of the seeding rate, 135 pounds an acre, was the best one, but combined also with a higher nitrogen. But on the lower zone, actually, applying more nitrogen did not provide us with more profit. Rather, increasing more seeding, going to a higher seeding rate, but lowering a little our urea application. So this is the kind of like insight you can have, and now base yourself on this for future planning and management for this field. Now, if you're watching this presentation, you think this is interesting, and you'd like to know more about this, how would you then join this? So Daniel, what would be the process for this? How would you be part of this? What is needed for this?
Exactly. Thanks, Felipe. So we want to introduce the opportunities for producers and agronomists to do these trials in Alberta and Saskatchewan as well. And so the process that we've worked through to streamline over the past 2 years is we work with producers and agronomists to identify a field that's representative of your operation. So, you know, if the majority of your land is mostly flat or mostly rolling, you want to pick a field that represents that. It needs to be about 100 acres or more in order to get enough replicates across the field. With that field in mind, you can then talk to our team here, and we'll have you fill out an online form to provide details about how wide your equipment is, the accuracy of your GPS, the type of trial you want to do, whether it be a seed rate only, a nitrogen rate only, or both, and a little bit on, you know, how those steps you want to take in terms of, you know, do we want to change by 10 pounds, 20 pounds for these trials. We'll start designing that trial, and at the same time, we'll send you a data sharing agreement that basically goes through, you're going to maintain the ownership and how you control that data. However, what we want to know from you is, can we use that data for other research? Is it going to be strictly for this project only? And can we use your name and your farm identifiers, or do you want us to strip that and it be anonymous? So once that agreement is signed, we'll send you the finalized trial, and you can say yes, no, we want to make some changes, and we'll go forward from there. Once the trial is ready, we send that prescription to you, or we can automatically push it through a platform like JD Ops to your seeder. And when you pull your seeding rig into the field, you're going to follow the provided guidance line and apply that prescription, and you'll seed the field as normal. Once seeding season's done, we'll reach out to you and ask for those seeding as applied files to confirm that you actually seeded the trial as expected, and to confirm that the trials are aligned as they should be. And we'll review those and make sure that the harvest guidance line is correct, or we can update that as needed. We'll send you that harvest guidance line. So again, when you pull your combine or multiple combines into the field, you're going to use that guidance line and harvest back and forth. And again, by doing so, we'll ensure that we get good data from each plot or each strip, and there won't be any strips to go clean up afterwards. Once the harvest season is done, you'll send those yield files back to us, or again, if you can give the research team access to JD Ops, we could pull those remotely from you, so very little work in that regard. Once we have the yield files, we import them into a DIFM, or the Data Intensive Farm Management machine learning platform developed by the University of Illinois. So we take that as applied seeding data with your seed and fertilizer, as applied information, as well as your yield data from the combines, and a few additional pieces of information, such as how much you paid for your seed, how much you paid for your fertilizer, and how much you're selling your grain, because again, this is an economically driven process and project. And we plug all that into the machine learning platform. It then spits out a consistent report that tells us what would be the optimal seeding or fertility rate for that season, both in a flat rate sense, as well as if a variable rate prescription or applying variable rate product would be economically worthwhile. So with that in mind, we then send that report back to you, and we can set up a meeting to discuss those answers and what types of trials you might be interested to do in the future. And there's also an honorarium to support the producers and agronomists who are doing this work. So as Felipe kind of mentioned, you know, we started small with 4 trials in 2024 to get some ground under our feet. We moved up to 11 trials last year, and in this year, and also again in 2027, we're targeting 25 trials per year in Alberta. and we're going all across Alberta. We're not just trying to stick to around Olds or to a specific region. We want to represent all the different soil types across Alberta. And we're also trying to introduce this, and we are introducing this into Saskatchewan as well, with 5 trials this year and 10 trials in 2027. And that's in both wheat and barley crops. And it can be feed or malt, and no restriction on the wheat type. And so with that, if you're seeing this, you're like, oh, I'm interested. Maybe you want to look at the form or fill out the form, or I'd like to talk to the research team about some of my questions, please reach out to us. We can talk on this for hours, as you can imagine. We can. And so yeah, take a picture or send us an email. I've got the email here on the last slide if you're interested to participate. Of course, we can't do this work without our funders, so we're very grateful to them for all the support we've had so far. And yeah, with that, we're happy to take any questions.
Thank you, Daniel and Felipe. It was very informative, and yes, clearly very data driven, which is great to see. I always kind of picture this as the next step, or the next phase, the next structure of on-farm research that can really provide the next level of insight into on-farm management, and really narrowing down some of those economics and as it relates to agronomic decisions. So we do have one question that's come in from Jenny Seward. For the on-farm precision experimentation trial, do we need VR sampled soil samples?
Yeah, not necessarily, Janie. If you have them, it's amazing. Like, right, it's another piece that we can utilize to come up with the rates that you want to evaluate. So we know how much nitrogen you might have there and how much is going to come from your organic matter as well. But not necessarily, right? So this is, I would say, a portion of this is also like later on, you might want to take those samples to understand why the responses were like that, but that's not a requirement here for these.
Okay, next question is from Paul Watson. Is there a conflict between randomization and how the typical seeding proceeds?
Okay, I'll say, like, if Paul could like just clarify, I'll try to answer here based on what I understood here. So the way that the randomization happens there, Paul, is a specifically type of like designs called Latin square, but it should not like influence anything. So let's say if you're talking about operation, for example, we would create the prescription maps according to your usual direction of seeding, and then we just import that into your display there, and your machine will do all the control. So there shouldn't be no effect there. I don't know if that answers your question fully. Dan
Yep.
has his hands up, so
I might just add to that when the trials are designed, there's no step that goes from your highest rate to your lowest rate,
as
because
well, yes.
they understand, like the University of Illinois who designed it understands that the equipment has capabilities or lags, and so it won't go from 200 down to your
Yes.
lowest 100. It will step it down and then step it back up.
Hopefully that answered your question, Paul, but feel free to question in more detail if we weren't able to
Yes.
answer that specifically. Next question from Christopher Waldenberger. Uh, are the rates provided based on variabilities like elevation?
So in this case, when the rates are determined, the plots are determined, they're not, Christopher. Later on, when the analysis is done, then elevation is taken into consideration. For the trial design, because we have them all over the field, we actually want to have, even like if you might want to say, oh, I know that this rate won't perform well here, for us to be able to like create the curve later on of response, it's important for us to have like even rates that you might know, like, I don't think this might work. Still, Christopher, as Daniel mentioned in the process, if you're like, maybe I'm not comfortable with these rates in this specific location, this was all like a conversation we usually have. Or let's say you want to tailor something. That's a conversation we have, right? So this is all like things, these are all things that we discuss through the process. I don't know, Dan, if you want to add anything, but
No, that's perfect.
So it sounds like Olds will work, within the realm of the trials and the project to make sure the output is still valuable within the realms of
Exactly.
some of the limitations and comfort levels of how the farmer wants to manage that field.
Exactly.
Perfect. Okay. We have no more questions popping up. Um, so we have 5 minutes left. So if there's no more questions, I think what I'll do is put this to a close. If anyone has any questions after the fact or curiosities or want to reach out to us for more details, all of us are happy to engage in conversation, be it to plot to farm or on-farm precision experimentation, to further delve into whether this is something you're interested in doing. We want to make sure that whatever gets implemented on the farm is valuable to you and is created with the least amount of friction in your normal operation. We all understand the importance of timely implementation of seeding and harvest. So all of that is taken very strongly into consideration to help answer some of these questions you have on farm. So thank you to everyone who joined us today. It was great to have everyone here. It was great to see all the questions coming in. We appreciate the engagement, and thanks to all the presenters for sharing this information. Um, and I just did see a question come in. Will a recording of this webinar be distributed? And maybe I'll see if Stacy has an answer to that question, who's doing all the tech in the background. Today we talked about the two different programs, Plot to Farm, which focuses on field scale in a randomized, replicated manner with larger strip trials to help eliminate some of that question of are we looking at something that's by chance or are we looking at something that we're more confident in making those decisions on? And then Felipe and Daniel talked about a more data-driven, prescription-based approach to answering the economic question of are we implementing the right seeding rates and nitrogen rates across this field based on variability across that field? Two different approaches to on-farm research. And I've always said this, there's if you look across Western Canada and even North America and different parts of the world, there's varying approaches to on-farm research. And at this point, I wouldn't say that there's one that is the silver bullet to everything because of the complexity of implementing on-farm research and the variability in the environmental conditions, the equipment that farmers are using. So having these multiple different types of on-farm research are valuable because it allows access to different farming practices, different farmers to still be able to tackle some of the on-farm challenges that they're dealing with. So again, if you're interested in learning more, reach out to us. Thank you so much for your time today, and your interest in on-farm research, and we look forward to engaging and having more conversations as things move on. So have a great rest of your day, and a safe seeding season as we head into seeding season. And Stacy, I don't know whether we got an answer to whether a recording. Oh, it looks like she's answering you in the chat there. So, thank you to everyone and enjoy the rest of your day.